Morning, fellas.
Morning.
Tyler, you missed out on the best class ever yesterday.
Maybe Tyler's gonna miss out on this class too.
Tyler, wake up. You fell asleep?
He's so bad.
What? What?
That'd be so bad if you got on the call and just fell asleep.
Yeah.
So what is supposed to happen in our lab?
Are you talking lab 9?
Yeah.
Just a minute, I'll pull it up.
Okay.
I know you're wondering, but the timer is still timing. What time are we looking at? Is it 9:43 or something like that?
I thought it was 53.
Oh,
We'll pay attention to both.
I'm gonna have to go back and look at the video. Well, I haven't uploaded that yet.
So I press the green button. Control relay 1 energizes. Green light turns on. And I press the yellow button and nothing happens.
Well, man, you just royally screwed that up.
Yeah.
Actually, I have no idea because I'm not looking at the ladder right now. But
Okay.
give me a second here.
I'm really thinking about starting over just because everything's a mess.
Sometimes that's needed.
Yeah. Okay.
All right, lab 9. Where'd you go?
Yeah. Do everything else we're doing today besides this 9?
We're gonna take a look at the NEMA timers.
Oh,
I'll
yeah, yeah.
do
I
a
was
demonstration
talking
of
about
that, and then we'll talk about the lab. All right, so here's lab 9.
Yep. Just wires.
All right, so we only have one stop. There's 2 start push buttons that should be wired in parallel. CR1, which one are you using for control relay 1?
Left iceberg.
Okay. All right, so think of that as like process start. Okay, so you've got some kind of process here that's run off timers and there's a motor.
Okay.
So you can hit either one of those two push buttons, and the reason for that is that this might look dumb, like why are there 2 buttons here? But this button might be like on the other side of a building, you know, so you can start
Yeah,
the
so you can
from
start it from 2
different
different
locations.
locations.
Yeah. So
Gotcha.
green pilot light turns on. All right, then push button 3 starts the timing process.
Okay.
So
I think that's what I do.
CR2, which is probably your right iceberg,
Yep.
is what holds all this holds all of this stuff. So you push the
I
3rd
gotcha.
button,
Yep.
and looks like nothing's going to happen until this limit switch is closed.
Okay.
Once the limit switch is closed, TR1 will start timing for 10 seconds.
Mm-hmm.
You can set your timer for 10 seconds if you want. I don't really care what the time is as long as it's enough time to see what happens here.
Right, not 1 second.
Right. So back up to this start 3 push button. Once that's energized, this red light should turn on. Right?
Okay.
Because this is normally closed.
Yeah.
And then limit switch is closed. LS1 closes, starts the timing
Mm-hmm.
process. After 10 seconds, the red light will turn off because this will open and the motor
Okay.
will start running.
Okay.
So after all the mumbo jumbo of starting the process, there's 2 control relays and a limit switch that have to happen before the timing starts. Once the timing starts, after 10 seconds, TR1 will open open the, it'll turn off the red light and turn on the motor starter. You see why that happens?
Generally, yeah.
On rung 8, this is a normally open on delay timer.
Okay.
I talked about the symbols yet, but if the arrow is up like that on a timer, that means it's on delay. So by now you should be pretty familiar with normally open and normally closed, right?
Mm-hmm.
So arrow is up, or think of it this way, the arrow points to the action of what that toggle does.
Yeah, then I got you.
So this is a normally closed on delay.
So when it's activated, it opens. When the other one is activated, it closes.
Right, so on delay means when that coil for that timer is energized, nothing happens until after the time elapses.
Mm-hmm.
Off delay would mean that when the coil is energized, everything changes state immediately.
Okay.
Okay, so if this was an off delay timer, this coil TR1 gets energized, this would close right away, and this would open right away. And then when this opens back up and de-energizes this, 10 seconds later, everything would change back. You get that? So there's two different types of timers associated with normally open and normally closed.
I got you.
Okay, so this guy here, Tyler, are you with us?
He is cached.
You know.
Cached. Here you go.
All right, so I'm going to go through this, go over this. So this is a NEMA timer. This one says off delay. So this is the opposite of the one that's shown on your print. So what happens with this one is, you remember the control relay that I showed you?
Yeah.
This plunger pulls in when you see the coil change states. The coil gets energized, this thing pulls in. Same thing with this.
Mm-hmm.
It's got this little knob on the front, and you can actually push it in and change the state of the contact. But this one has 2 contacts. I won't zoom in and show you, but this one shows that the left side is normally open, it looks like, and the right side is normally closed.
Okay.
Real quick, I'm going to take this timer off. Check this out. You watching? Watching?
Yeah.
Watch. I'm going to take this timer off. Whoa.
Yeah, they're the exact same thing.
Yeah. So this one is just tacks onto the front of it.
Yeah.
Right?
So could you put the timer on the front of the other one?
Yep. That's what these little holes are here for. And this actually operates off of that red plunger.
I gotcha.
So you see when I took it off, this thing receded. If I push it back on there, it pops out. So this is the same as actually pushing in on this. And you can still use, so if I have this tacked on there, you can still use this. You know, you got 4 sets of contacts here that are just not run off of that timer, right?
Yeah.
So we have this, and then we have the timer with its 2 contacts. So anyway, I'm going to take this bad boy apart, show you how these things work. Before I do, this little knob here is what you would use to zoom in on this. This little knob here is what you would use to increase or decrease the time. And it says,
Yeah.
actually, if you take this thing off and flip it around on there, then it would become an on delay timer. I'll show you why.
Okay.
You see the mechanics of it.
Yeah. That's why those are so nice, because you can change them around. Ours are just stuck.
Yep. You can change them around. You can replace parts. You can replace the contacts if the contacts get burned up.
Mm-hmm.
They're very robust. Take this here. And this should all look familiar. It's the same type of contacts that are on the this one. So you can change these from normally open, normally closed just by flipping them around. I'm not going to do that because you've already seen it. But I'm going to take the timer part off so you can see the spring. So inside of there, you can see the mechanics of how this thing operates. So remember, this plunger shows what happens, how the contacts change state. I'm going to, on the back side, push this thing up because there's a spring in there that holds it in this position until the coil energizes. So you can see the mechanics of what happens inside there when I push that thing up. This little guy opens up.
Mm-hmm.
So this goes down, this thing comes up. And if you look at the back side of this, the timer itself, this little plunger is actually what operates the timing part. And then if you move this dial, all you're doing is increasing the tension of the spring that's inside that plunger. So,
and then that's how that changes the time for it to decompress.
it actually runs off of air. It's kind of like this little diaphragm. Let's see if I can do a demonstration here. So I'm going to decrease the time. You can see as I wind this thing, the little screw inside there is working its way down towards the bottom.
Okay.
I'm decreasing the time that it delays. And I'm going to push this in and watch how quickly it comes back out then. Ready? Pretty quick.
Yeah.
Boop. Now if I
yeah.
increase the time all the way to the top, and then I push it in and watch how slowly it comes back out. See it coming back out?
Yep.
Very slowly.
Slowly. Yeah.
So that's how one of the NEMA timers work.
Okay.
Back together. So I'm just looking at the one that's on the trainer behind me to do a demonstration.
Okay.
Your lab is set up for on delay. Would you rather see a demonstration with the same on delay, or would you rather see an off delay? I guess I could do one of each.
Yeah. On delay would be good because the timers are a little bit confusing right now.
It won't be too difficult to. I'll do one of each.
Yeah.
Just for the sake of.
The one that's not sure about the ones we have here is the percentages. What do the percentages mean?
Oh,
Because it looked like the one you had there didn't have any percentages.
no. So that's how you adjust the time on these.
It's pretty blurry.
You see it now?
Yeah.
Okay, so let's say we wanted to run this thing at 5 minutes.
Okay.
How would you do that?
Oh, gotcha.
For T1.
I gotcha.
So for T1, then you would set this at 10 minutes times 50%, right?
I got that makes sense then.
And then these two dials are for T2.
Yep.
And still,
All right. I thought for a while that was the amount, the percentage of power that was being allowed. That seems strange.
no.
Gotcha.
I'm gonna look up real quick what time this thing is supposed to change state.
I bet it's 43, but it could be 53.
You wanna bet? What are we betting? One free
I don't know.
assignment?
Yes.
If it's 53,
Absolutely.
if it's 53, you get one free homework assignment. If it's 43 and I win, then you have to teach one class.
That's gonna be a terrible class.
Doesn't matter. I can sleep in.
All right. I guess I can try it. Definitely worth the risk.
There's a lot of work going on at my job. Mine's pretty hard. What? I said mine was pretty relaxed.
problem with yours is, well, on this lab, you shouldn't have a problem with that. The problem with you, fascinate too.
Theory.
One day, 100%. Damn it, you win.
I do win.
I think. Look at what time it is. 9:52.
Yes.
You should do is you should hook up a bunch of fancy lights to set them to go off on the last day of class.
That was a great idea.
I'm gonna some fancy lights.
Yeah.
You could have these things time off of each other, right? They just flash. All right.
Yes.
One free homework
You
assignment.
get to pick which one I get the free homework assignment on.
Yeah, I
so-
really want you to do the VFD one. So what ones do you have left? Here, let me stop recording so I can't. All right, so I'll use this TR2. And what I'm going to do is I'll run it off a push button. Let's see. So I'll have this control relay, since it's already set up with the green button, that will turn on the coil of TR2.
Okay.
When that happens, I'll run one side, one contact to a red light and one contact to the yellow light. I gotta make sure. Yeah, so the left side is normally open, the right side is normally closed. And then what I'll do is I'll run it once with the time delay on delay so we can watch what happens with those lights. And then I'll flip this thing around and we'll do off delay. So we can see all.
Okay.
What we can do then is move some stuff. red light is going to be on the left, the yellow light will be on the right. Steel screw of this. All right, so what should happen here is I've got everything running off of this control relay first. So the red light is run to the normally closed. The yellow light is run to normally open. So when I turn this thing on, the red light should be on and the yellow light should be off. Whenever this timer changes state, they should flip. So right now we're set at and on delay. So normally closed, normally open, on delay. So that means when I energize the coil, nothing will happen until however many seconds later. Let's just pretend it's 10 seconds. We'll count. But I can increase the time. Ready?
Yeah.
I guess yellow is normally closed. I guess it's backwards. Can you see that light on?
Yeah.
Okay. All right, so I'm going to go ahead and energize the coil. 1001. Oh, that was quick.
Instantly switched.
That was really quick. I'm going to increase the time. 1001, 1002, 1003, 1004, 1005. About 5 seconds. Okay, so that's on delay. Do it one more time. Normally closed. I energize the coil. You'll see this plunger pull in. You probably can't see it on camera, but that's what's happening.
Yeah, it's pretty big.
So you'll hear it click. You'll hear this relay click, which will energize this coil, and it'll also click at the same time.
Okay.
1002, 1003, 1004, 1005. So normally after 5 seconds, normally closed opens, and normally open closes. Turn it off and just flip this thing around to make it an off.
Okay. Yeah, to where it's normally off and then it turns on. I got you.
Okay, so now it's an off delay. So what should happen is when that coil gets energized, it should change state, and then after the 5 seconds, it'll change back.
I gotcha. Yeah.
So I should push the button and it changes state. 1001, 1002, 1003. Oh, wait a minute. So it'll stay like that until it'll stay like that until I kill it. So after it's de-energized, then we'll count to the 5 seconds and then it will change state.
Okay. Yeah, it'll stay on for 5 seconds. I got you.
Yeah, off the way. So 1001, 1002, 1003, 1004, 1005. See the difference?
Yeah. Yep. One, it turns it off. The other, it stays on until.
That's energized. It changes state. I'll kill power to it. 1001, 1002, 1003, 1004, 1005. Kind of cool, huh?
Yeah.
So you got all sorts of options depending on how you set up the timer itself.
Yeah.
So any questions on any of that?
No, I probably would if I was doing it, but just seeing it, it seems pretty simple. Yeah.
A lot of people get confused with the off delay, on delay, normally open, normally closed, and all the different symbols. But if you run it through your head, the first thing you got to understand is the on delay, off delay with the timer. So the solid state one that we have on our little trainer is it's on delay, right?
Yeah.
So you energize the coil and it doesn't change state until the time elapses. So, by the way, we're 3 minutes away from our
Yeah.
I know you're excited.
It'd be pretty cool if it worked right on time, though.
I'd be really impressed if it was within the minute.
Yeah.
Am I doing this? Share screen 2. I'm gonna pull this up. Oh, it just changed state. Oh, I missed it.
Pretty perfect.
9:51. There's 2 minutes off.
Still pretty good, though.
Pretty darn good. I'll show you here.
Yeah. Everything's going.
You can't even see the light. It's all right. All right. Well, that's all I have for today. Unless you got questions.
Okay.
You're just going to work on the lab.
Yeah, I've got one question.
What's up?
So on lab 9, by the junction of start 3 and control relay, normally open 2, would it work to run the normally open CR2 down to the push button and then run everything off your proto board? Is that right?
You mean use your proto board as like a terminal strip?
Yeah, pretty much.
Yeah, there's nothing wrong with that. Just keep in mind that you only have 5 in a row, so you could have like a little jumper there. I guess.
Yeah, that's what I'm doing, is jumpering.
Yeah. Yeah. No, that's fine.
Okay.
I mean, in real.
I was making sure that would electrically work too, not just practically.
Yeah. Well, in the real world, you're not going to have proto boards strapped to your equipment, but like you'll have terminal strips, like you got mounted to the DIN rail next to your timer, so. But yeah, I don't have a problem with that.
Cool.
we're gonna do it again. 9:53. You ready?
Yep. 9:53. Maybe I can win the bet twice and not do any homework this week.
Yeah, I'll forget tomorrow. All right, timer started. 1 day.
Okay, so. And what is the S on the timer?
We were talking
Once
about
on the
that
top of the-
yesterday a little bit. I think it's it energizes as it's timing, so I think you can use it for a counter. You know, if you wanted to
Okay.
send like a little 24-volt signal to a counter or something for every second
Mhm.
or whatever the.
I got you.
I'm going to stop recording here.